Okay, I believe now anyone can join anytime. No problem. Okay. All right. So this is a new course. I think if you have not studied before, so from the beginning to end, everything will be like ABCD. Okay. So meaning that you will be learning something new. Okay, on this course. So that's why I seek your attention seriously. Okay. And this subject is very, I can say, interesting. Okay, if you understand. Okay, because it is like a mathematics. Okay, when you understand, okay, so it will be very easier for you. Okay, to solve the problem, definitely to score in the exam. Okay, but you must understand. So without understanding, it is very difficult to memorize. You should not think that. Okay, you must understand first. So okay, so to understand, you have a different few things that you have to follow. One is you must attend the class and follow the class. And yes, you are welcome to ask any questions during the lecture or after the lecture, or even after finishing any lecture anytime. Okay. Second one is discuss each other. Okay. After the class, the topic that we have discussed, so you can discuss with your class friend. Maybe you can make a group, your own group, maybe two or three. Okay. If you like two, if you like three, okay, just discuss what we discuss, whether you understood or not. What you understood, explain each other. Okay. So this way, actually, you can understand better, and you can what call keep in your memory. Okay. So when you tell others, whether your friend understand or not, your understanding will be better. Okay. This is the purpose. So discuss each other. So and definitely you can ask anytime. Okay. So I will try to explain. Okay. And third is when we finish any topic. Okay. All right. Sometimes I will give you some assignments. So please practice. Okay. Please be active with the assignment. So when you practice the assignment, actually you can you can improve your understanding better. Okay. Because you have to solve some problems. Once you solve the problems, actually things will be very clear to you. Okay. So that's a for every situation, practice is very important. Okay, without practice, your learning will not be completed. Okay, so that's why we have to follow the some assignment. All right, and when you do the assignment, actually it will give you some advantage. That is, you yourself develop your understanding. Same time you can do better in the exam, because those are the assignment actually either same or similar type will be in your exam. Okay, so in that case it will be easier for you. Okay, and one more thing is I like to clear to you. I uh, i never give any questions that I have not discussed in the class. Okay, all right, so meaning that you should not be problem to score your in your exam, because whatever I provide in the exam, I must discuss in the class. Okay, maybe they're not the same, but when I discuss in the class, maybe I'm discussing something. In the exam, it's coming similar thing, maybe with changing some data. Okay, changing some data. So that's why the class attendance, class understanding is very important. Okay, especially with me. Okay, so that's why should not be worried. I'll do my job. You have to do your work. Okay, that's thing. So follow my instruction. Okay, so this is the course synopsis. So the course This course will cover the components and process of hydrologic cycle. Okay, I'm not sure whether you have heard about the hydrologic cycle. Okay, shortly I will explain. Okay, and the statistical methods of hydrologic calculation. Okay, hydrology cycle means you have heard about the rainfall, you have heard about the temperature. Okay, so this is the rainfall and temperature is a component of a hydrologic cycle. Okay, then you have heard about the runoff. Runoff. I think you have heard water flow in the river. That is also hydrologic component. Water flow in the soil, also hydrologic components. Okay, so that is the hydrologic component. So in this course, we will try to understand what is the occurrence of behavior of every component and how we can estimate. Okay, how we can estimate, or maybe sometimes we have a data, how we do the analysis, and based on the analysis we do the decision making. Okay, so decision making, actually there are many decision making we have. Okay, hydrology is a common subject. There are many peoples are it is used by many peoples. Okay, many discipline people, like our agriculture engineer, we use this one for mainly for crop production and protection. Okay, because hydrology is the flood and drought. Okay, means when you have a heavy rain we have a flood. This is actually hydrologic. And when we have no rain, very hot, or maybe few weeks no rain, then we can see that there is a low flow in the river. Even sometimes we have a problem with the water supply in the house. Okay, because of shortage of water. So that is called drought. Okay, so hydrology and drought. So this is also the component of hydrologic cycle. All right, so this thing we'll discuss in this course. And sometimes we need to do some measurements, means observation, like how to collect the temperature, how to collect the rainfall, those things. And then with then this data we have to do the analysis, because without analysis we cannot make any decision. Okay, so in this subject mainly we'll practice how we can do the analysis and make the decision. All right, the second paragraph is the movement of water in the soil and between the phases of soil discuss. Okay, so water movement in the soil, this is also the part of hydrology, because water comes from the rain. Is it our main source of water? Actually the rain. Okay, rain. Because why? Because without rain we cannot get the water in our lake, our pond, in our river. Okay, so actually the water source in the rain, but actually not the rain. Water source actually main actually main source actually the sea, the big one. Okay, ocean. Okay, ocean is the main source. Okay, there are some other source, shortly you will know. Okay, so these are the components mainly. Then we will do some data analysis. Okay, so why you do the data analysis? So it is mentioned here, data analysis, it is for efficient water resource management. Okay, so this is the purpose of hydrology. So hydrology is the unique, this is the one system. So this system actually embedded by the hydrologic cycle. So all the components actually within the hydrologic cycle, like our human body. Okay, we have hand, we have eyes, we have nose. Then when we join each other, when we join all of these things, actually we can say, okay, this is the complete man or human. Okay, so similarly, so hydrologic cycle, actually there are few components. So this all of these components, when you can see all of the components actually each other, there is some interaction. Okay, so we need to understand the occurrence and dynamic process, and then based on this we have to analyze the data. After analyzing we can make a decision whether it is drought, whether it is a flood. When we have a flood, what to do? When we have a drought, what to do? Okay, so there are many kind of decision you can do, right? And different people uses different purposes. Our purpose is agriculture. Okay, like civil engineers. Civil engineers, they study hydrology for water resource study, city, okay, city management, water supply to the city. Okay, we also can do this practice because the theory is the same. Okay, theory is the same, but application is different. So meaning that once you study hydrology, once you understand the hydrology, you can work as a civil engineer. Okay, no problem. Okay, only you are studying now in a different place. You are studying under agriculture engineering, civil engineering student under civil engineering, but the same subject, same topics, no difference. Application is different. Okay, so later I will explain why is the difference. Okay. Okay, I believe this is not correct now for the time being, but I think or maybe right. Yeah, C4 and C4. This is your course outcome. Okay, so course outcome is at the end of your course, you will understand and you will learn those things. Okay, first thing is you have to understand the hydrologic cycle all and its components, and you will do the analysis. After analyzing, you can evaluate or assess, or you can make a decision making for water resource management. All right, this is the thing. And this second and third one is your discussion with each other. When you understand from my lecture, you explain each other, you talk to each other, share your opinion. What is this? What is that? How you understood? How you explain it? Okay. So this is your part. Okay. So please do that. Okay. Okay. So this is the briefly I show you the syllabus. Okay. This is the hydrologic cycle, statistics for hydrology. So have you studied statistics before this in the semester 1 or semester 2?
Yes.
General statistics like mean, standard deviation, regression. I think you have studied, is it? You have studied that
Yes.
course, then fine. So it will be fine. Okay. So here statistics or hydrologic analysis, it is a different, but you need that knowledge. Okay. So that is a general statistics. So after this, we have a advanced statistics application in different aspect. You can use for hydrology, you can use for water resource, you can use for environment, you can use for chemical engineering, whatever. Okay, manufacturing. Okay? So different purposes you can use. So this is statistics for hydrologic analysis. Then we will do some rainfall analysis, then infiltration, evapotranspiration, runoff. So this is a number 3, rainfall. Rainfall is a component of hydrologic cycle. Infiltration also component of hydrologic cycle. Evapotranspiration also component of hydrologic cycle. Runoff is also component of hydrologic cycle. Okay. Then this is some application. Once we know this is a hydrograph. What is the hydrograph? I will tell you later. Okay. But hydrograph is simply it is a graph actually. Okay, something like maybe I can say simply understand this. Otherwise, you say what is the hydrograph? So hydrograph actually is a simple thing you can understand now. This is the time. Okay, this is the time. So this time can be any unit. It can be in second or minute or day or hour or year or month or weekly, 10 days, anytime. Okay, anytime. And the y-axis is you can say flow. Okay, okay. Flow means here flow means water flow. Okay, you can say the ditches. You can say river flow. Okay, sometimes called river flow. Okay, sorry, I'm writing now my mouse. Okay, shortly I will use my iPad. because it is charging. Just a few minutes. So this is a river flow. So meaning that river flow simply we use, we use the Q, okay, Q, and time normally we use by T, okay. So meaning that hydrograph is actually presentation of water flow or discharge or river flow with time, okay. So maybe the graph is something like this. So if you have a time, so by time you can know what is the flow, okay. So now you can see this is the maximum here. So this is a hydrograph. And stream flow frequency analysis. So hydrograph is a Q here, and stream flow frequency. Frequency, you have studied the uh, frequency. What is called histogram in your statistics. When you studied statistics, you have studied histogram, is it? Am I right? Histogram, something like a class interval like this. Okay? Maybe 0 to 10. Sorry, 10 to 20, 20 to 30. You have studied this histogram, am I right? Okay.
Yes. Yes,
Okay.
sir.
Yeah, okay. So this is a similar type. So here stream flow, this is the frequency actually, frequency. Okay. So we have a data. So that data we will analyze by histogram, and after this beyond. Okay. You have studied until histogram, but we use histogram, but after histogram we will do something else. Okay. For the decision making. Okay. So this is the stream flow analysis. Then another option, another is the groundwater. So groundwater is this is the surface. Okay, this is the surface. So groundwater is under the soil. Okay, because when we have rain, so rain falls on the surface, and then this water enter into the soil. After this, after some time, the water start moves on the surface. So this one is a groundwater, and this one is a runoff. Okay, we call runoff. Okay, runoff. I think everyone is familiar with the runoff. So, but this is a hydrologic component, all right? Groundwater. So we will discuss groundwater a little bit, not much. And this is the some analysis. As I mentioned, we will study the hydrologic components. After this, we will do some analysis. So one of the analysis is very important analysis is steam flow frequency analysis, very important. Another one is also hydrograph analysis. Another one is a flood routing, or maybe we can say routing. Okay, routing means the routing. Routing means we know the flow behavior. So means when water flows from one place to other place, what is the behavior? Means characteristics of the water flow. Okay, you can know the amount, you can know the velocity, you can know the location. Okay, how far is it? Okay, and this is some applications, means current applications. How this subject can be linked with others. So one of the application is very important now, climate change. Okay. So this is optional. I will not discuss all here, but I will discuss with this one. This is not very important. Okay. But I will give little bit as this one. And if possible, we will do some okay, applications. So this one is solely will be carried out under maybe the lab. Okay. I'll try. Okay. And this is your lab. Okay. You can see the rainfall, evaporation, weather station, evapotranspiration. So these are all of this the hydrologic component, and this is some analysis. Okay. All right. This is some of the reference books you can follow. I think those books are available in your library. But beside this, you can have a lot of books. Okay, I will share also some books when I discuss the lecture. Okay, after this. All right. Okay. So this one is just you can read it. Okay. Just to understand what is the hydrology. Okay. You can read with it yourself. Okay. I just read for you. Okay. This is the occurrence, distribution, and movement. Occurrence means something is happening, like rain. Rain occurs. Okay. Rain falls. Okay. This is the occurring. Then after rain, this rain distribute everywhere. Is it in the soil, over the soil? Then this water goes to the river, goes to the lake. This goes to the drain, goes to your pond and lake. Okay. So this is the distribution and movement. And sometimes it stores, like in front of our faculty we have a lake. Is it small lake? So after raining, water comes from surrounding areas, so water comes to this lake, so that is called distribution, movement, and the storage. Okay. After this you have a quality issue and quantity. Okay. So whether this water is a good water, rain is a good water, but once falls on the ground it can be polluted. Okay. It can be polluted. So that's why one of the part of hydrology is the quality control. Okay. So if you want to do the quality control, you have to manage your land. Okay. Your land should be covered by grass, not by soil. Okay. Like if road is empty, so means your water will be polluted after raining. But if road is your not road, not only road, all the surfaces, land surface. If land surface is covered by vegetation, forest, okay, then your water will be good quality. You can see, you can observe uh, those areas, land is covered by forest, and if you go nearby, then you can see the water at that area, river water is clean, very clean. Okay, all right. But the area, there was a forest before, maybe there is no forest now. They have done some development, they have made some houses after clearing the forest. You can see the nearby any river, the water quality is very bad, very bad. All right, very bad. So that's why the quality, water quality depends on our management. Okay, how we manage our land surface. Okay, so that's a vegetation cover is very important. Okay, I will show you few of the examples. Okay, later. Okay. So then we will collect those data, then we do the some deterministic analysis. Okay, deterministic means something okay, this one. I give you simple example. A equals pi r square. Okay, okay. This is called deterministic, meaning that if you know the circle, if you know the r, you can calculate the a. So this is the deterministic. Okay. Then we have a stochastic. We have some okay simulation. So that's the different thing. Okay. So the hydrology can be defined as the science and deals with the space. Space means the place, one place to other place in the time. Okay, like if you see the rain occurs at different place. Sometimes some places no rain, some places there is a rain, and the time is how long. Okay, and the frequency, how frequency it does rain occurs every day, every hour, or maybe every 3 days or every 7 days. Okay, so these are the characteristics: space, time, and frequency. Let's say frequency means how often you can get it. Like you attend this hydrology class, let's say only Monday, so meaning that once in a week. Okay, yeah. So meaning that your frequency is once in a week, means once in a 5 days. Okay, because Saturday Sunday is holiday. So this is your frequency. All right. So those are the things we discuss. Okay, and definitely as I mentioned, this is related to occurrence, distribution, movement, and storage. Okay, storage means the water source that we hold the we store the water, then this water we can use later, okay, for different purpose, for agriculture, for water distribution, for the housing or city water supplies, okay, those things. And this is the scope of this hydrology. You can see here we have many branches of hydrology. Hydrology is the main, and you can split many branches. One is mathematical branch, mathematical hydrology. So mathematical hydrology means this branch, they develop the theory and models. Okay, those we apply for other. But our hydrology is not mathematical hydrology. We use it, but we will not develop. Okay. Then another is numerical hydrology. So these are the advanced mathematical, numerical. This one is advanced, means when you study hydrology, this course, later, maybe in your masters or maybe in your year 3, when you have a special applied applied course, that is optional course, you can do this. Then digital hydrology, system hydrology, parametric hydrology, empirical hydrology, statistical hydrology, stochastic hydrology. So there are different branches we have. So this is the type of analysis. But type of application is users. We have civil engineering, chemical engineering, environmental engineering. Okay. Then what is called agrohydrology, agriculture. Okay. We have a many. Then weather and forecasting. Okay. You can see those are giving the weather and forecasting every means okay, today or next 3 days we can have a raining this amount, this area. So this all of these are hydrology, right? So we have, there are many branches like hydrology, chemical hydrology, biological hydrology, so many things we have. Okay, generally. So this one just give you search, then fine. Okay, now I am trying to give you the understanding about the hydrologic cycle. Okay, and I think you can see these animation pictures. You can see the occurrence. Then what occurrence after this? What we see? Few terms: occurrence, distribution, and movement, and storage. Four things, is it? You can see here. Occurrence means like rain occurs, and this is the distribution. Okay, then what? Movement. Okay, distribution and movement, there's moving. And the storage, you can see the storage is, it can be stored in the river, stored in the lake or pond. Okay, we have, like in the faculty of engineering, we have the lake. So before storing the water, we have the rain that is occurring. After this rainwater move and distribute. Okay, moving means maybe on the surface, under the ground. You can see here, this is the moving on the surface, and this one moving on under the ground. You can see the blue rays here sometimes. So this water moving to the ground and coming here. This is the water, groundwater. I think everyone knows that we have a different source of water. Is it? One is surface water, another is groundwater. But the main source is a rain. Rain occurs, then this rain distribute and move. You can see here, moving and distribution to the surface. Surface means river, lake, pond. Okay, and another one is the ground, under the soil. After that, then it goes deep and deep and deep. Finally, there is a good place. Good place means actually the underground. We have a stone, we have a sand, big gravel, so where you can store the water. But this water is not static. This water is always moving, dynamic. You can see this water has a connection here. Okay, this connection here. So this is not full now. So once it is full, this water will move and move with this. Okay. So meaning that this is a hydrologic cycle. So meaning that water is continuously moving. You can see here, and starting point is from here. Mainly the sea, ocean. Okay, ocean, all the open surface like lake, river. So lake means like our faculty of engineering, we have the lake. So something like this. Okay. So, but it is triggering by sun, means temperature. Without sun, water will not move. Okay, because every process, I think you know this, every process actually start when we have some difference. Okay, like difference means you have studied the hydraulics. Some of you know that when you have elevation difference, and then let's say water is coming, we join the pipe. Okay, so I think everyone understand now. If you have a water here, so this water will move from high to low. So meaning that there is some differences. Okay, elevation differences. You can see this is the differences. Okay, these are differences. Okay, so water will move. Okay, so in that case, the sun actually plays the pivotal or main role. Okay, because when we have a temperature differences, so sun actually activate. Okay, sun emitted the heat, and then water surface becomes hot, and then it start evaporation. Okay, you can see this one. So this is, you can say, this is the starting point. Start from sun, then it start evaporation. Evaporation means like a boiling water. Okay, when you boil the water in your house, you can see the water is started evaporation. Okay, boiling. Okay, but this evaporation occurs from different sources. One is open water source. Open water source is what? Open water source, you can have an ocean. Okay, you can have ocean, you can have a lake, you can have a river. Okay, you can have a river. Is there any other thing? Any other other water surfaces, small surfaces? Okay, then you have a plant or trees. Okay, because you can see this plant, this plant, this plant has the root. Okay, this root. So this root is goes down like this, and this root has, under the soil you have a water. You can see this is the water. So plant uptake the water. You have studied by from soil science or maybe from agronomy. Okay, take the water, and when we have a temperature, so there is some reaction here. So due to that reaction, the plant removes some water through the leaves. Okay, so that process is called transpiration. Transpiration. You can means plant removes the water through the leaves. This is called transpiration. And also some soil surface means here empty soil. Okay, because you can see if we have an empty soil, then if let's say you have a rain today, the soil is wet, but after this, if let's say 3 days, 7 days, or 10 days there is no rain, the soil becomes dry. Okay, very dry. So meaning that you have some evaporation here. So that is from the soil surface. So from soil surface also have a evaporation. So this process is called E. Okay, evaporation. Evaporation is from soil, also from the open water surface. But transpiration is from leaves, plants. Okay, and E and T. So this is a combination. Actually, we call evapotranspiration. Okay, I will write before later, but this one you can see here, evapotranspiration. This one you can write here. Evapotranspiration. So evapotranspiration actually combination of evaporation and transpiration. So evaporation from soil and transpiration from the plants or trees. So combinedly it is called evapotranspiration, because it is very difficult to determine or separate E and T. Okay, because you can see anywhere in a location surrounding, there is a plant, there is a soil, but plant is not everywhere. There are some open space, okay, but covered by trees. So that's why you have a two things. One is a T, that is transpiration. Another is evaporation from the soil. Like these two trees you can see here. So the water moving from the leaves, this is T, transpiration. Okay, you can see the transpiration. Okay, maybe I can write here. It's called transpiration. Okay, TRAN. I'm not good in writing by mouse. Okay, anyway, you can write the transpiration. Okay, I see my charts whether it is okay or not. But anyway, today should not be a problem. Next time I will be ready. Okay, this is called transpiration. But you can see the spelling here, evaporation. This is the evaporation. But when we combine together evaporation plus transpiration, we call evapotranspiration. So this evapotranspiration actually from the surface. Surface means on the surface, on the ground, we have a plant, we have a soil. So this together is evapotranspiration. All right. Okay. So now we can see. So sun is very important. Without sun, this thing will not start because sun will create the difference, temperature differences between two places. Because previously it is if water is cold, the evaporation will not start because you know that if you want to start the evaporation, you have to boil, you have to heat the water. So sun actually plays that role. So once sun emitted the heat and water becomes hot, then evaporation start. This you can see. Then this evaporation goes to the sky as a vapor form, gas form. Then above actually the temperature is low. Okay. So when the vapor goes, then this vapor make condensation and make the cloud form. After there is some process, okay, it makes the ice or crystal form, and there is some force. Force means there is some upward force and downward force by this cloud. Cloud means cloud is a crystal form of the vapor. Okay, maybe the ice or something. You can see when you fly, then you can see the pattern of the sky. Okay, you can see the very big white. Okay, so those I think all the crystal or ice form. Okay, something like this. So anyway, there is upward pressure. So when this upward pressure is low, then this water or ice or cloud, then this one start dropping. So there is some mechanism. Okay, so this water that falls on the ground. So it process from the evaporation by sun. You can see here. This is the evaporation from the cloud. Then rain falls on the ground. Okay, so our purpose, we are not very interested for this evaporation. That evaporation from the ocean, that is not in our part because we don't do agriculture in the ocean. But evaporation in the river, evaporation in the lake, that is our part. Okay. Anyway, this is the rainfall. Then rain comes, rain drops on the soil, and then you can see after raining, the water enter into the soil. Water enter into the soil. This process is called infiltration. This one you can see right here. Infiltration. The process of entering rainfall into the soil, it is called infiltration. So not only rainfall, even if you drop water on the soil, so water will enter into the soil. So this process is called infiltration. Infiltration means water entering into the soil. How much water is entering? This is the rate of water. Rate of water entering into the soil is called infiltration. So it is a rate means it can be, unit can be millimeter, let's say per hour, sorry, millimeter per hour, or maybe millimeter per minute. Okay, so this is called infiltration. This is the rate. Okay, after infiltration, so this water moves slowly. Okay, slowly moves. The velocity is very low, maybe 0.1 meter per second. Okay, velocity, not much. Okay, velocity is very low. When water moves into the soil, it's very low velocity. Okay, all right. So this process is called percolation. Okay, this is the infiltration. After infiltration, there is a process called percolation. Percolation. So this percolation have a two terms. One is called percolation, means moving down and down. Another is called deep percolation. Okay, deep. Deep means it goes very deep. Something like in this area, then come to deep. This is the deep percolation. Is called groundwater. Okay, right. So when water moves under the soil, we also call subsurface. Subsurface flow means underground flow. Okay, sub means under the soil. Okay, subsurface flow or groundwater flow. Okay, and then this rain, after entering into the soil becomes saturated. You know the saturation. Saturation means maximum holding capacity. Like uh, I give you the example. Let's say this is the glass. Sorry, just consider this is the glass. So this glass, when you have a water, when you fill the water, so the glass has some capacity. Okay, some glass has some capacity. Once glass is full, if you still try to fill it, so the water will spill out. So meaning that maximum capacity is this glass is this. So this is maximum capacities. Okay. After this, the glass cannot hold the water, so it will spill out. So this is you can say saturation. So another way to understand is I can say, just a minute. Maybe let's say this is the glass, and here you have a water, and you can hold a one cloth. Okay, just a cloth. Okay, one cloth. You just hold one cloth by your finger or hand, and then this cloth you just soak here. Okay, this cloth, then it hang it. Once you hang the cloth here, okay, by your hand, then you can see the water is dropping here. Okay, at the beginning, and after some times there will be no water is dropping, but your cloth is still wet. Okay, so meaning that the clothes hold some water. This is a maximum holding capacity of the water. This by every system has some capacity, holding capacity. Okay, so that is the maximum capacity or optimum capacity. So every soil, different places, because we have a different types of soil. So every soil has some holding capacity. Once exceed this capacity, then water start to move. This one you can see the moving. So this is a exceeding after exceeding the capacity. So this is what is called runoff. We are familiar with the runoff in the hydrology. Then this runoff goes to the river. Okay, goes to the river, lake, whatever. Then continuously by sun, this one is making the evaporation, then coming back, going back. Okay, so this is actually water is moving from one place to other place, from the ocean, from the trees, from the lake, from the rivers, from the cloud, then drop on the soil surface or plant, then these move and distribute, and then again. So this is things are happening. Okay, so this is called hydrologic cycle. Okay, and here is called condensation. So this is the condensation here. Okay. So this is the process of hydrologic cycle. So if you understand this one, you don't need to memorize this one. Okay, so you have mainly the evaporation and evapotranspiration. Evaporation is from, it occurs from the two places, one from the water, another from the empty soil. Empty means where there is no plant. This is called empty soil. So meaning the water and soil. Okay. So evaporation occurs from soil and water. And transpiration occurs from the plants. So evaporation from soil and transpiration from the trees or plants, it together is evapotranspiration, like this one. Okay. Okay. So this is the evaporation. So this evaporation from soil. Okay. And transpiration from the plant. Okay. Plant or trees. So this together is evapotranspiration. Okay. But evaporation from the ocean, then the river or pond, this is not the evapotranspiration. Evapotranspiration actually it is the where you have a plants like forest, like your agricultural field, your crop fields. If you grow something like paddy fields, your vegetables, your fruits, okay. So where you have a evapotranspiration, okay? This is the thing. So this one is a more details. Okay. Just let me try whether I can connect my iPad or not, because I cannot write. Just a minute. Now charge is 33%. Hopefully I can run for sometimes. Yeah. You can see here very details here. Okay. I Yeah, I think today will be difficult because I need to do some settings. Repeat just a minute. Okay. I have to start here. Where is this? Okay, do you have any questions? Okay. Okay, I think now it is okay. I can. Okay, you can see here very details. There previously it was not very details. You can see here same thing, but so many component. You can see, as I mentioned before, this is the sea. So where evaporation start. Okay, evaporation is from sea, then also from the lake and from the soil surface. Soil means this is the soil, is it? So here soil surface. So we have here also soil. Okay, so this is the evaporation. So this is evaporation, then moves to the sky, then make a condensation, make the form the cloud or rain, then falls as a rainfall. So this is the down, you can see here this arrow. So this is the rainfall. Okay, this is the rainfall. And this rainfall, when falls on the ground, So instantly the water enters, rainfall or water enters into the soil. That is called infiltration. So infiltration is very important in the agricultural application. Okay, because we need to know how much the rate of infiltration. Okay, so every soil has a different, okay, infiltration rate. Like if you see the city area there is no soil, all are covered by cement, concrete or road surface. So there is a infiltration rate is very small. So there is water doesn't penetrate into the soil. So most of the water goes to the river. Okay, right. All right. So and then, as I mentioned before, the evaporation and transpiration. And transpiration occurs from the plants. Okay, plants. Okay, plants. So plant means it can be forest, it can be agriculture, it can be crop, anywhere. So evaporation from soil and transpiration is the transpiration from the crops. Okay, crops or grass. Okay, or forest. Okay, so this. So those evaporation from soil and tea from plants or crops. So this combinedly we call ET. So that is called evapotranspiration. Okay. So evapotranspiration is a combination of evaporation and transpiration. So evapotranspiration. Okay. So it is very important for our agriculture engineer. Okay. Very important evapotranspiration. And another component is the rainfall. So these two. Okay. Temperature is also important, but later you will see evapotranspiration and rainfall are the most important. Also the infiltration. Okay, these are the very important, but not in this subject, other subject. So that's why in this subject we will learn the basic occurrence distribution, how we get the evapotranspiration, how we get the rainfall, how we get the infiltration. We will know the occurrence, distribution, and movement only. Okay. Later, once we understand how to collect this data, how to analyze this data, later you can use this thing to other subject like hydraulics, irrigation engineering, water resources, groundwater. That is the application of hydrology. There are many applications. Okay. And then water, when after the infiltration, the water moves to the ground and then moves under the soil. So this is called subsurface flow, sometimes called groundwater flow. You can say many things, right? So those are the fact of the hydrologic cycle. All right. So this is the continuous and dynamic cycle. It is happening continuously, like every day. Okay, you wake up, you do some activities. Okay, during the daytime, then nighttime you go for bed, you sleep, then again you start everything. This by 24 hours. So hydrology cycle also have their own cycle. Okay, so maybe cycle start at certain time and finish at different time. Some maybe 1 day, some maybe 2 days, some maybe 1 year, some maybe 1 month. Every system has a different. It depends on the what called place. Place means characteristics of the area. Some area is flat, some area is mountain, some area is no forest. So we have a different, so many options. But once we know how to do this, how to analyze, then we can explain the pattern, we can explain the behavior, we can explain the characteristics. Okay, so that is actually part of the hydrology. So it is very important for the different disciplines. Okay, including agriculture engineering, civil engineers. Okay, so for the agriculture engineering, we use hydrology for crop production. So definitely, basically, but you are able to work in any industries with your knowledge because the theory is the same. Okay, theory is the same. That's the thing. All right. So don't worry about this. Don't say that I cannot use as a civil engineers. Civil engineers learn more. No, you can do better than civil engineers. Okay, I will tell you later. You will know everything, but civil engineers will not know everything. Okay, civil engineers, they are limited to city only. They don't come to agriculture. Okay, so your understanding will be better than civil engineers. So you can play better role. Okay, that is my understanding. I will explain, then you will say yes later, not now. Okay, so this is the for today's actually I mainly focus on course introduction. I give the some hydrology and hydrology cycle. Okay, now I will explain. We have a few minutes. I just explain the what is the watershed. Okay, just this thing. Later the this slide I will share with you. Okay, so please read this slide, then you can understand hopefully, because this slide there is no technical things, but I just explain this watershed. What do you mean by watershed? Okay, before this I just like to see whether I have any picture or not. Okay, so this is the hydrology cycle, also same thing. You can see evaporation, cloud form, rain. Okay, infiltration, water is moving, surface length, also same. Okay, I'm looking on, this is the different areas. You can see, you can read it, you can understand. Nothing is technical, but I'm looking on picture. Otherwise, I'll draw. Okay, I got it. Okay, so watershed. What is the watershed? Have you heard this word watershed before? Anyone?
No.
No. Okay, very good. Okay, okay, watershed. Okay, have you heard this one? Catchment, CATCH, catchment. This one, have you heard? Then another one is called basin. Another one is called drainage area. So these four actually the similar thing, but we use for different purposes. Watershed, catchment, basin, and drainage area. There are four, you can say synonyms. So it is an area actually. If I say watershed, then what is this? So all of this actually the area. You can say it is the what is area. Watershed is a area. Catchment is a area. Basin is the area. Drainage area is the area. So it is the area. Okay. So what is the difference then? Why it is we say Sea Sardang we call Kajang, but Sea Sardang Kajang is the area, but it is not a watershed. Understand my point? So what is the watershed then? Watershed means you can see this. How I can explain you? Okay, let's say this is the boundary. You can see the green boundary, green area. You can see here green area, and there is a boundary. So when rain occurs, rain falls here, rain falls here, rain falls here, and rain also falls here. Let's say here, rain falls here. Okay, but this rain on falls this area, but this rain doesn't enter here, this boundary. It doesn't enter inside the boundary. It goes this way. Is it possible or not? Okay, and then rain drops in this area, and this rain, all the rain accumulate and flow like this, and it comes to the one place. So this area is called one area. So this area called a watershed or drainage area, meaning that after raining, water from this area comes to this. You can see the river, any river. You can see from your college. Okay, Okay, I can give you the another example. Maybe here, this one. Okay, this is the surface. Okay, this is the surface and this is the subsurface. Okay, try to understand here. So this is the rain occurs on this surface. The green one is the surface. Am I right? Clear now? This picture. Can you see this picture?
Yes, doctor.
Okay. Now please respond me. So this is from this surface we understand very simply. We understand. You can see the arrow, the black arrow. So the black arrow shows that water flows from left to right side. Means this is the water flowing. This is the water flowing. This is the water flowing. So meaning that this area here is a lowest area. This is the lowest area. Lowest area, and this side is the higher area, high. So we know that water flows from high to low. This is by gravity. Everyone knows. So definitely, let's say this area, I just make a one boundary here, like this area. This is the boundary. So if water falls here within this boundary, is it possible this water will flow here, will come here? That circle I made it, because this area is high, this area is low. Is it possible water can flow low to high? It's not possible, is it? Because water flows by gravity. Water always flow from high elevation to low elevation. So this water will never go here. Okay. That's why you can see here we have a different, like this one is one stream, this one is one, maybe this one is another one. Okay. So this is this is the one watershed. This is the another watershed. This is the another watershed. This is the another watershed. Okay. We have a many watershed. Okay. Like this picture you can see. I have made a few dot. If I say this dot. So watershed is very simply, if you say watershed, what is the watershed? Watershed, it is the area. What is the watershed? Okay. I just explain this one, then I will stop. Hopefully you can understand. So watershed, it is called area. It is area. So it has a defined boundary. Defined boundary. So meaning that it has a defined boundary like this. Okay. It has a defined boundary. And it has a single outlet. Single outlet. Meaning that in this area, anywhere water drops, this all water at the final stage, it will come here at this called lowest point. So meaning that every watershed, you have a one lowest areas. Lowest means when you have a lowest area, so meaning that once water drops anywhere, so this water will come to here. Okay, so meaning that if I say this is the point, and if I say based on this point, what is the watershed? So meaning that maybe this one. I just draw just roughly, maybe this one. This is the lowest point. This is the upper point. So meaning that any rain comes or occurs, so this water will come here. But if I say what is the watershed for this point? This point is connected with this area. You can see this area, also this area. So maybe by this. So entire area. If we consider this point. If I consider this point, maybe like this. But if I consider this, maybe entire area. If I consider here, so this is the watershed. Entire area is the watershed. So watershed is different on your outlet. Outlet means where you measure the flow. So every outlet is, you can see the red one, red one, red one. Every outlet is look like something like this. You can see here, this is the river. This is the real map. This is the real map, and this is the big watershed, and this is the red one location. This location is this place. You can see the river. So meaning that water from this area comes to this river, and we can measure it. So meaning that how much water produced in this river that comes from this watershed. So watershed is the area we call basin, we call catchment. Okay, all right. It is an area and it has a boundary and it has a single outlet like this. Okay. So now if I say, if I consider the point here, what is the watershed then? So then our watershed is maybe this one. Okay, because water from this area will not go here. Only water from this area will come here. So it has an outlet. Outlet means discharging water, the place. Means rain occurs and then this rain will flow and then it will move through one point at the one point. Okay, so this is called watershed. So when you study the water, when you study the hydrology, we don't say Kajang, we don't say Sisadang, we say watershed at Kajang, watershed at Sisadang. So we have to determine, we have to delineate. This one we have to create it. So this course you will know how to create it. Okay, this one. So Sisadang is an area, but watershed is different. Watershed is defined by based on the water flow. Okay, so meaning that a particular area water flows and accumulate together at a particular point, meaning that this area water collect from all of this area and it comes this place. So meaning that watershed for this area is the entire area. But outside, water, if water falls here, water flows here. Okay, sorry. Okay, water, if rain drops here, rain drops here, this rain never enter this. Okay, something like, I can give you the example. Let's say this is the hill. If rain drops here, what will happen? This water will come this direction, will never go this direction because this is the peak. If rain drops here, this rain will drop this area, will not go here. So meaning that this area is not watershed of this point. Maybe this point is like this. Okay, so this is the, so meaning the watershed, it is an area, it has a clear boundary and it has a outlet where all water from this area will be discharged. Okay, so this is called watershed. Clear now? Maybe you can be clear later again. Okay. Something like our faculty, you can see our faculty entrance. Okay, you can come to the different lab, you can come to the different building, but when you go out, you have only one outlet. So this area, if we consider it, it's like this. So meaning that any area you have a, but this is not the vehicle, only for water. The flow is water. Means this area, water falling here, water falling here, water falling here, water falling here, water falling here. So meaning that this is the area that water is, this rain is occurring. Then all the water actually finally it flows, it comes from far areas, come from close areas, but it finally is come to this area. You have a single outlet. Okay, so meaning that it has a clear boundary and it has a discharging outlet. So this area is called watershed, catchment, basin or drainage area. Okay, so when you study hydrology, we don't consider Kazang, Sardang, this. We consider as a watershed. Based on the watershed, we do the analysis. Okay, so I like to stop here. Okay, if you have any questions, you can ask few questions, then we can stop. I think it is 10 o'clock now. Maybe you can have another class. Any questions?
No, doctor.
Okay, so maybe you can proceed for the other class. Sorry, still have 1 minute, I believe. Okay, I will update later, so maybe we can discuss during the lab. Okay, because during the lab we'll do some discussion. Okay, I will give some additional information to you. Okay, I think we can stop now. you can leave and you can join for your class. Okay. Okay. Thank you very much. See you again.
Thank you, Doctor.
Okay. Welcome.
Thank you, Doctor.
Thank you, Doctor.
Doctor.
Okay. Welcome, everyone.
Thank you, Doctor.
Welcome. See you again.